What is up, amigos? Today we're looking at the aerodynamics of the Netherlands, and this comes on the heels of our video from a couple of weeks ago where we looked at the aerodynamics of Germany, and we thought, is the lower lands going to be more aerodynamic than the fatherland? Who will reign supreme, the Netherlands or Germany? And we'll find out at the end what the drag coefficient is of each country. So we have these plains downstream here, and we can see immediately the Netherlands is quite fiddly, like it has quite a lot of peninsulas around. You have the ones like south of Eindhoven and the one around Den Haag and then like Amsterdam and etc. And interestingly, even though you have all these little peninsulas, the wake behind it seems to really become quite circular quite quickly. The first plain behind it, already we can see that a lot of the features from the Netherlands have really been like mushed out, and it's just a general wake. Then we go into the second plane and third plane, it's just really just circular, and then we die down into a regular wake breakdown kind of structure. And these wakes are very dynamic, like they definitely are not stable, they just break down very quickly. And you can see in the center of each one of these planes, particularly the third and fourth planes and fifth planes, that the flow is actually quite fast in this center region, and around the outside it is very slow, and we'll get into that a bit more with other planes. And we have the sub-drag plotted here on these exact same planes, and unsurprisingly the drag is quite high. Like this is predominantly dominated by the pressure drag, which is when you have a bluff body, you have a lot higher pressure upstream compared to downstream. That creates this resistive force. But interestingly, building on that wake that we saw before, if you look at the outside edges, particularly of the third and fourth planes, the color is much redder than in the middle of the planes. And this indicates that it's the outside edges that are really producing a lot more of the drag. And now we have a Y plane going straight through the middle of the Netherlands. So this is like going straight through Amsterdam and kind of a little bit east of Rotterdam. And the wake, as you'd expect, is very big. However, at certain parts of this flow, you can see that there's a little bit of flow moving back towards the Netherlands, sort of like kicking in the pants. And this is kind of reducing the drag of the Netherlands in total, because if you have fluid going back into it, it's hitting that surface and like kind of propelling it forward a little bit. That's why the outside edges were producing more of the drag than the middle part, as we saw earlier. So this is the exact same plane now with a total sub-drag plotted. And we can see that, as we mentioned earlier, that around the edges, we can see that there's like these little localized regions of very red flow, and that's very high drag. And then in the middle, there is still quite very orange flow, but there are little pockets of more orange and even yellow flow. And that indicates that there's a little bit less drag in this region. So it definitely is the edges of this shape that is producing a lot of the drag. And now we have a plane going through like around Den Haag area. And we can see like this little peninsula here is incredibly draggy. So you have like just a fairly small cross section, but you look at the wake, it's like 3 or 4 times the width of the structure that it's actually coming off of. This indicates that this region, which is where all the politicians are, by the way, is very draggy. And we'll see later if that really affects the drag enough to make Germany more aerodynamic than the Netherlands or not. And now this is the exact same plane, but with a total sub-drag plotted. And generally speaking, I think you could probably conclude that the top half of this part is producing a little bit more drag than the bottom part, because you can see periodically there are significantly more of these red zones that are being shed off the top part than on the bottom part. So I think the bottom part of the peninsula is probably a little bit less draggy than the top part. And now we have a Z-plane about halfway up the Netherlands. And it might just be my imagination, but I think probably the west part of this structure is producing a bigger wake than the right structure. What do you think? Let me know in the comments below if you agree with that or not. And the sub-drag, the total sub-drag plotted here on this exact same plane, kind of indicates that we do have a lot of unsteady drag production on each side. So what this means is that the total drag of this structure fluctuates with time, so you need to take an average of it. So in this next video, we're going to see what the drag coefficient of the Netherlands is compared to the Germany, and see if it will overtake it or not. Now let's have a drum roll. Oh, we're almost here. The Netherlands beats Germany by about 4%. The drag coefficient is 1.05 compared to 1.09 for Germany. And Bosnia and Herzegovina, unfortunately, has a drag coefficient of 1.16, which we found in the video from last week. So we can conclude that the Netherlands is more aerodynamic than Germany in terms of the drag coefficient by about 4%. We'll look at other countries in the near future. Let me know what you want to see in the comments below. And if you like this video, make sure to click the like button. And if you want to see more videos like this, click the subscribe button for you. And I'll see you next video. Peace out, amigos.